So for question 2, we are looking at the number of positive integers between a certain range that are divisible by different numbers. So let's begin by looking at 2a. So we are looking at positive integers between 100 to 999. Now, so essentially this is a range of integers starting from 100 all the way to 999. Now, we are looking for numbers that are divisible by 7. So now we realize that if a particular number is divisible by 7, then the next number that is also divisible by 7 is going to be a distance of 7 integers away. So if we are looking at how many numbers are divisible by 7, it's similar to looking at how many, this range from 100 to 999, how many interval of 7 could actually fit inside. So let's look at this range, and this range essentially contains 900 numbers from 1000 to 999. So we imagine that, if we start from 0, let's say, to look at this in a more complete picture. So now from 0 to 999, there is going to be 0 to 999. So here there are 1000 numbers, right? From 0 to 999. So within these 1000 numbers, how many of them are divisible by 7? So we just look at how many intervals of 7 we can have. So if we evaluate this number, it's going to be 142. In terms of integer, there is going to be some remainder, which we don't need. Now, but this is a range from 0 to 999, but we only are concerned with 100 to 999. So which means that this particular range from 0 to 99, we want to exclude it. So 0 to 99, which is to be excluded, has 100 integers, and 14 of them is going to be divisible by 7. So if you take the difference, 142 minus 14, so we have 128. So the answer to 2a is 128. Alright, so now we look at 2b. So in the case of 2b, we are looking at how many of them are odd. Now, we know that every odd number is followed by another even number, and then followed by another odd number and an even number. So if we just look at the numbers that we're actually dealing with, so we start from 100, which is even. Now the next number, 101, is odd. The next number, 102, is even again, and then odd again. So we have even, odd, even, odd, even, odd, and so on. So essentially half of the numbers are going to be even, half of the numbers are going to be odd. So 100 to 999, so there are 1000 integers here. I'm sorry, there are 900 integers here, because we are only concerned with 100 to 999. So there are 900 integers, and exactly half is going to be odd. So then we have 900 integers divided by 2, so we have 450 odd integers. So that is 2b. Okay, so we're now going to move on to 2c. So how many integers have the same 3 decimal digits? So 3 decimal digits means the same number, we are going to repeat it 3 times, because all the numbers between 100 and 199 are all 3-digit numbers. So now if you look at all the possible 3-digit numbers, so we will have 000, so we have 111, 222, 333, 444, and so on. all the way to 999. So whichever number we pick as the first number, we just need to repeat it 2 more times, and we are going to get a 3-digit number that has all the same integers. Now, but because of the range that apply, 100 to 999, so we have to exclude the first one. So then we only have 9 possible numbers that remain. So in this case, we are going to have 9 possible outcomes for 2C. So we are now going to look at 2D. How many numbers or integers are not divisible by 4? So not divisible by 4 could be a lot of numbers. So we're going to use a strategy here to exclude numbers that are divisible by 4. So, so we have all numbers are either divisible by 4. So, some number are divisible by 4, and some numbers are not divisible by 4. And the sum of all those numbers are going to be essentially all the numbers that we have. Now, all the numbers that we have, because we have a range of 100 to 999, so we have 900 numbers. And the number that we are interested in is this one, which is not divisible by 4. So then we need to work out how many are divisible by 4. And 900, so out of 900, the ones that are divisible by 4, so we essentially have 225 here. So then we just need to work out this difference between 225 and 900 to get the numbers that are not divisible by 4. So here we will have 675, which is 900 minus 225. Alright, now let's then look at E, which are the numbers that are divisible by 3 or 4. So in this case, there are 2 possible ones that we are going to consider: divisible by 3 or divisible by 4. So let's first consider the ones that are divisible by 3. So since there are 900 numbers there, so we are going to have 300 that are divisible by 3. Now, the numbers that are divisible by 4, we worked it out earlier, which is 225. And then we are going to have some double counting here, because numbers that are divisible by 3, some of these numbers are themselves divisible by 4. And similarly here, these numbers that are divisible by 4, some of them are going to be also divisible by 3. So we are going to consider numbers that could be double counted, and these are essentially numbers that are divisible by 3 and 4. And that will be the lowest common multiple of 3 and 4, which will be 12. So if you consider these numbers that are divisible by 12, so we have 75. So the total then, that are divisible by 3 or 4, we need to take the number that are divisible by 3, the numbers that are divisible by 4, add them up, and then we need to remove the double counted ones, and the double counted ones are the ones that are divisible by 12. So then we minus 75, so then we end up with 450. So that is 2E. So we are now going to consider 2F. Now, the 2F is concerned with numbers that are not divisible by either 3 or 4, which means that whichever numbers that were included in 2E, they will be excluded by 2F. So since we know that 450 will be divisible by either 3 or 4, the ones that are not are the remaining ones. So to work out that number, we need to consider all possible numbers, which is 900, and then we minus off the ones that are divisible by 3 or 4, and we get that from the 2e before, so this is 450. So then the total answer, the final answer is 450. So this is for 2f, which is a complement of 2e. So 2e plus 2f should make up the full number of 900. Alright, so now we're going to consider 2g. So for 2g, we are interested in numbers that are divisible by 3, but not by 4. So earlier we know that the numbers that are divisible by 3, these are 300. Now some of these inside here are also divisible by 4, and in 2g we want to exclude them. So since the 300s are divisible by 3, and then we may need to minus off within this 300 that are also divisible by 4. These are the numbers that are essentially divisible by 12, which is 75. So then we need to exclude this from the 300. So then we are going to get 225. So this is 2g. Now the final part is 2h, and 2h is asking how many numbers are divisible by 3 and 4. Now we actually did work it out earlier, and we say that, you know, divisible by 3 and 4, it means that essentially they are divisible by the lowest common multiple of 3 and 4, which is 12. So numbers that are divisible by 12 will be divisible by 3 and divisible by 4. So since that number is 75, as we worked out earlier, the answer to 2h is also 75.